Grade 7s, welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all well today and looking forward to the lesson. Just a reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to use it to send me any feedback, any questions. Perhaps there's a topic you'd like me to cover moving forward, and I'll be more than happy to have a look at that for you. Today we are going to be looking at 3D shapes, and on either side of that main theme we've got our warm-ups and our mental arithmetic questions, and then our brain bender and finisher at the end. Our warm-up today is on the screen. You need to tell me the value of each symbol and the question mark at the end. Just a reminder of order of operations. Please check your work thoroughly. There's no rush, take your time. And let's see how you guys get on. A bit of trial and error here. I put numbers in and see if they worked out. In the beginning, I actually forgot about the order of operations, and then I had to go back and start again. So making those kind of errors is fine as long as you learn from them and you recognize those mistakes. So ultimately what I ended up with was the pancakes with 10. And one of the mistakes I made is that I said 10 times 10 first, where it should be the second pancake divided by the strawberry first, because division comes before multiplication. So 10 divided by 20 is a half, and then 10 times a half is equal to 5. That would be the correct way of doing it. Okay. Now that we know that the strawberry is 20, we know that 20 multiplied by 10 is equal to 200. Okay. The strawberry, as we know, is equal to 20, and the pancakes are equal to 10. So 20 divided by 10 is going to be equal to 2. So the egg is equal to 2. Then what divided by 2 is going to give me 40. Okay, so the coffee must be 80, because 80 divided by 2 is 40. And we know that 70 is going to be equal to 80 minus 10. Okay, and then right at the bottom, we know that the egg is 2, the strawberry is 20, and the cup of coffee is going to be 80. So we need to do multiplication first. So 2 times 20 is 40, and 40 plus 80 is equal to 120. Okay, so I hope you guys worked through that and you remembered the order of operations. Divide before multiply. Addition comes after both divide and multiply. And yeah, I hope you guys worked that out. If not, press rewind, work through it again, and try and make sure that you understand the concepts that we're dealing with. Mental arithmetic questions are on the screen. There are 9 of them, all based on topics that we've covered before. So I encourage you to work through these slowly. Remember the checking strategies. Remember we spoke about writing everything down to make it visually clearer and more understandable for you. Work methodically, logically, keep it as neat as possible, and yeah, let's see how you guys get on. One is the addition of decimals, and let's just have a quick chat about this. So it's 178,910, so we know it's 100, it's 70, it's 8 units, it's 9 tenths, it's 100th and 0 thousandths. That's if I had to expand that number. And 158,762 is 150, 5 tenths, and 8 units, and then 7 tenths, 6 hundredths, and 2 thousandths. Just notice that I mentioned the number when I mentioned 178,910. It's not 178,910. Okay, that would be the wrong way of saying that number. So after the decimal, the numbers are said individually, and then 158,762, not 158,762. Okay, that's just a small technical bit there. But then we just add normally. Okay, we know that the decimals line up, and we know we must carry when necessary, and then we should get an answer of 337,672. The check strategy is if we take 337,672, and let's subtract 158, 762, and if we get 178,910, then we're going to know that our calculation is correct. So let's just finish this one off. 12 minus 5 is 7, 2 minus 1 is 1, and there you can see that 178 is the same as the 178,910 at the top. So our calculation must be correct. You could have said 337,672 subtract 178,910, then you should have been left with 158,762. Either check strategy is absolutely okay. Right, your next question in question 2 is a subtraction of decimals. Okay, and if we write that down, that's 837,1. And remember, 837,1 is exactly the same as 837,10. And then subtract 438,1. And I'm going to just put in the 0 so that everything balances out. And I've got the same amount of digits at the top as at the bottom. For me, it's just visually a little bit more pleasing. We know 0 minus 0 is 0. 1 minus 1 is 1. Decimals always line up. We need to borrow, so it becomes 17 minus 8, which is 9. We need to borrow again, so 12 minus 3 is 9, and then 7 minus 4 is 3. Remember, the check strategy is to do the inverse. 0 plus 0, 0, good. 0 plus 1 is 1, okay, good. 9 and 8 is 17. 9 and 3 is 12, and 3 and 4 is 7. So if all those work out the way they do, then I'm happy and satisfied that my calculation is correct. Okay, long multiplication next, and we've spent a lot of time talking about various strategies. So the one I'm going to use today is going to be a compensation strategy. So I'm going to say 156 multiplied by 20. Okay, remember that multiplying by a number ending in 0 is really straightforward. So if all I'm going to do here is I'm going to say 156 multiplied by 2, which looks like that. And that's going to give me an answer of 312. Okay, but then I must remember multiplying by a multiple of 10. So I need to add that 0 on the end. Now all that's left for me to do is to add another 156. Okay, because then it will make it 156 multiplied by 21, and we can add that straightforward, and that's going to give us 3,276. But let's have a look if we could have done another method, and the other method I'm thinking about is doubling and halving. Okay, so let's see how that works out. I'm going to halve 156. Okay, and half 156 is going to give me 78. I'm going to double 21 to 42. Okay, both even, so I can go again. I'm going to halve 78 to 39, and I'm going to double 42 to 84. Okay, and that's where I'm left. What you could do here is you could do another compensation method, and we could say 40 multiplied by 84. Okay, let's create some space. 3276, let's just write that down. Okay, so now I'm going to say 4 times 84. So 80 times 4 is 320. 4 times 4 is 16. Put those together, you're going to get 336, but then I must add that additional 0. Okay, so 3,360. What I now need to do is I need to take off 84. Okay, so I originally had 39 groups of 84. I went and worked out 40 groups of 84. I now need to take off 84 to make it 39 groups of 84. And let's see how this works out. 10 minus 4 is 6. I can't do 5, so I need 15 minus 8 is 7. 2 minus 0 is 2. 3 minus 0 is 3. And you can see I get the same answer, so both methods will work out. You may absolutely do the column method. You'll get exactly the same answer. Okay, but by now I'm sure you realize that I like to use different methods. It just helps us to understand the way numbers are composed, how we decompose them, and how we can actually manipulate them to make our calculations that much easier. Okay, question number 4 is division. All right, and it's short division because we're only dividing by a single digit. So we'll take this as 19,004. We're dividing by 2, so we're halving it. So we know 2 doesn't go into 1. 2 goes into 19 9 times. 9 times 2 is 18, so we're left with 1. Remember the decimal lines up. 2 into 10 goes 5 times. 2 doesn't go into 0. 2 goes into 4 twice. Now if I wanted to check that, okay, I can do the inverse, which is multiply. So it's a short multiplication sum. And let's have a look at what we get. 19,004. The answers are the same, so therefore our original calculation must be correct. Okay, then we move on to question number 5, which is a subtraction of fractions. And you'll notice that we have a mixed number, 1 and 2 fifths, not divided, minus 3 quarters. Okay, so what I'm going to do is I'm going to convert that mixed number to an improper fraction. I need to find the lowest common denominator of 5 and 4, and yes, that is 20. 5 goes into 24 times, so 4 times 7 is 28. 4 goes into 25 times, so 5 times 3 is 15. And that's going to give us 28 minus 15 is equal to 13 over 20. And that's as simple as that answer gets. Okay? Right, let's move on to question 6, which is the division of a number by a multiple of 10. And at this time, it is indeed 10. And we know that when we divide by 10, the number becomes one place smaller. Okay, so that's going to give us an answer of 23,16. Question 7 is 1/2 divided by 4. Okay, we know that we can write 4 as 4 over 1, just so that we have 2 fractions. Okay, when we divide fractions, we change the division sign to multiply, and we invert the fraction after the division sign. So now we've got a half multiplied by a quarter, and that gives us 1/8. Okay. Question 8 is the multiplication of fractions, which follows on quite nicely from question 7. Okay. And the 2 fractions involved are 2/3 multiplied by 3/4. Now you may absolutely just multiply the numerators together. 2 times 3 is 6. And the denominators, 3 times 4 is 12. And you'll see you get 1/2. But remember, it's easy this time. But if the numbers are a lot bigger in your fractions or in your questions, then that simplification process at the end can be a little bit tricky, and you can be inclined to make careless errors. So we've spoken about cancelling out diagonally. So 2 goes into 2 once and into 4 twice. And 3 goes into 3 once and 3 goes into 3 once. So now my numerators, I've got 1 times 1, which is 1. And at the denominator, I've got 1 times 2, which is 2. And that helps me avoid having to simplify 6 over 12. Okay? And then your last question is to find 10% of 320. And I've always said my preferred method to find 10% is to simply divide 320 by 10. And that's going to give us 32. All right. Alternatively, you could say 10 over 100 multiplied by 320 over 1. We know that 10 over 100 is 1/10. Okay. And now we can simplify diagonally. 10 goes into 10 once, and 10 goes into 320 32 times. And you can see now the numerator, we've got 1 multiplied by 32, which is 32. And in your denominators, we've got 1 multiplied by 1, which equals 1. And we know that 32 over 1 is equal to 32, and you can see both methods give the same answer. For me, just dividing by 10 is a lot easier than doing all those calculations with the fractions at the bottom of the screen. But as I've always said, you guys must choose what you are most comfortable with. Okay, let's go have a look at the main theme of today, which is 3D shapes. Okay, so 3D shapes, we're going to start talking about faces, edges, and vertices. Okay, so 3D shapes are defined by the number of faces, edges, and vertices that they have. And as you can see, vertices are indeed the corners of this 3D shape. So the shape on your screen is labeled a tetrahedron. Okay, and let's have a look at faces, edges, and vertices. So that is going to be your face. Okay, your edges are where the arrow is pointing to and the line identified in blue. And then your vertex, which is one corner, is indicated by the red dot. A tetrahedron is a pyramid with triangular faces. So you'll notice that all the faces are triangular in shape. So there is one face at the bottom. There is another face right at the back. Then you've got the two faces which are facing you on the screen. So altogether they have 4 faces. Edges, they are being highlighted in blue. Okay, and you can count along as they get highlighted. So that's 3, that's 4, 5, and 6. So edges is 6. And then the last thing we need to work out is how many vertices does a tetrahedron have? Okay, and how many corners is that? And you can see that the red dots are going to give you 4. Okay, so that's the tetrahedron, faces, edges, and vertices. Tetrahedron is the simplest of all the 3D shapes. Here we have a square-based pyramid. Okay, and you can clearly see it's called a square-based pyramid because its base is a square. So if we had a look at the faces, there's a triangular face, there's a second triangular face, there is the square-based face at the bottom. Okay, you have that green face, and the next green face gives you 5 faces. Edges are 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so nicely identified there for you. And vertices are 5. Okay, so that is a square-based pyramid. I would like you to now go and have a look at these 3 shapes. They've already been named for you. So the shape in number 1, the pentagonal-based pyramid, is named like that because its base is a pentagon in shape. There's another pentagonal-based prism in number 2, and again its base is a pentagon. And then we have a cuboid in number 3, and its base is a rectangle. So go ahead and go work out how many faces, edges, and vertices each of those 3 shapes have. Shapes for you to identify: a cube in question 4, a hexagonal-based pyramid in number 5, because again the base is a hexagon. Remember, a hexagon is a shape with 6 sides, and the hexagonal-based prism in question number 6. Right, off you go. A cube, you should have 6 faces, 12 edges, and 8 vertices. The hexagonal-based pyramid is 7 faces, 12 edges, and 7 vertices. And then the hexagonal-based prism is 8 faces, 18 edges, and 12 vertices. Okay, now that we've spoken through and explained faces, edges, and vertices and how many there are of each in several shapes, I wanted to just chat to you guys about Eulers Formula. So Leonhard Euler was a Swiss mathematician many years ago, and he discovered a connection between the number of faces, the number of edges, and the number of vertices in polyhedrons, which is another term for three-dimensional shapes. Okay, and this applies to convex polyhedrons. So what I'd like you guys to do is to press pause when I'm finished explaining, and I'd like you to work through the number of faces, the number of vertices, and the number of edges of the triangular prism, the square-based pyramid, the cube, and the rectangular prism. Rectangular prism is another name for a cuboid. And I'd like you to see if you can actually go work out the formula by yourself. When you press play, I will work through this table with you on the Google Jamboard, and hopefully you guys can make the connection once we've done that. Right, off you go. Okay, so let's check it out. In a triangular prism, there are 5 faces. Okay, there are 2 on the sides, there's 1 on the bottom, and then there's the other 2 sides. So 2 triangular and 3 rectangular faces gives me 5 faces, right? The number of vertices, so the number of corners, is equal to 6. And the number of edges, if you calculate them, is going to be equal to 9. So what we have then is 5 plus 6 minus 9, and that's 11 minus 9. That's going to give us an answer of 2. Okay, let's go on to square-based pyramids. The number of faces on a square-based pyramid is 1 square-based face and 4 triangular faces, so it's 5 faces. The number of vertices is going to be 5 as well, so there are 5 corners. So the 4 corners of the square base, and then the apex at the top of the pyramid. And the number of edges, if you count that up, is going to be equal to 8. So there we have 5 plus 5 minus 8, and that's going to give us an answer of 2. Again, let's have a look at the cube. The number of faces in a cube is 6. The number of vertices is 8. Okay? And the number of edges is 12. So if I said 6 plus 8 minus 12, that again is equal to 2. I'm hoping you guys are starting to make the connection here. The last one, the rectangular prism or cuboid, is going to have the same 6 faces as the cube, the same 8 vertices as the cube, and the same 12 edges. So you can see that again, 6 add 8 subtract 12 is going to be equal to 2. All right? So Eulers Formula stated that the relationship between faces, vertices, and edges of any convex three-dimensional polyhedron is going to be equal to 2. So faces plus vertices minus edges is always going to be equal to 2. And it's a really cool, useful method to use to check your work whenever you have to name or calculate the number of faces, vertices, and edges of a convex three-dimensional polyhedron. Guys, this brings us on to the game of 24, which is our finisher for today. By now, I'm sure you know that you need to use each of the 4 numbers on each card, along with a combination of the operational signs, and you need to come up with the answer of 24. It's really important to remember your order of operations: divide, multiply, then add, subtract, and see how many different ways you can come up with the answer of 24. Grade 7s, thanks very much for tuning in today and watching your mathematics lesson brought to you by WorksheetCloud. Keep an eye out for the online activity and memo that will help you consolidate the work that we've learned and that's been taught to you during today's lesson. Please remember to send me any queries or questions or feedback and suggestions to grade7@worksheetcloud.com. Have a really cool day, keep safe, and see you guys next time. All the best.